Hello, amazing people. You're welcome to the third video in this series of stoichiometry where we've been dealing with this topic in depth. Well, in this video, we're going to be talking about the mole ratio. I trust you've been enjoying this video series. And if you're here for the first time, my name is David and I'm a tutor, a high school chemistry tutor for kids. Let's get into what we have for this video and see if we can learn a thing or two. So mole ratios are what we're talking about in this video. Let's start by defining what mole ratios mean. A mole ratio is simply the relationship between substances in a balanced chemical equation. How do we get the relationship between substances in a balanced chemical equation? Well, it is given by the coefficients in a balanced chemical equation. Let's take an example. We have this equation of nitrogen reacting with hydrogen to form ammonia. If you look very closely, this equation is balanced, and it's balanced because of the presence of the coefficients. For the nitrogen element, there is a coefficient of 1. Even though there is no number depicted over here, it automatically means that nitrogen is standing alone and there is a number 1 in front of it. I trust you understand that. How about for hydrogen? You can see a number 3 standing in front of hydrogen. So let's put that down. And then we have ammonia, a number 2 standing in front of it. So if we're to get the mole ratio, it now becomes 1 ratio 3 ratio 2. This is the mole ratio for this chemical reaction. It was gotten using the coefficients in the reaction. So the mole ratio simply tells us that 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. This is where the mole ratio comes in. The mole ratio is 1 ratio 3 ratio 2. Remember, 1 belongs to nitrogen, 3 belongs to hydrogen, and 2 belongs to ammonia NH3. So we have 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of ammonia. And we were able to depict that statement because of the mole ratio. So the mole ratio is very, very important where you have chemical calculations that involve chemical equations. So that balanced chemical equation gives us a map, and that map helps us to depict the mole ratio. Let's take another example. From this equation on the screen, we have the equation of hydrogen reacting with oxygen to produce water. We can actually extract several mole ratios. Let's see how many we can. So the mole ratio for hydrogen and oxygen would become, how many parts of hydrogen do we have in this equation? You can see there's a coefficient of 2. So let's write that out. 2 ratio. For oxygen, how many parts of oxygen do we have in this chemical equation? We have just 1. There is no number standing in front of oxygen over here, so it means oxygen is just 1. So we have 2 ratio 1. So the mole ratio of hydrogen to oxygen is 2 ratio 1. What this simply means is that 2 moles of hydrogen reacts with 1 mole of oxygen. That's not all. We can also get the mole ratio of hydrogen to water. So if we are asked to find the mole ratio of hydrogen and water, it becomes, how many parts of hydrogen do we have? We have 2, so let's write that out. And how many parts of water do we have in this equation? We also have 2. So it becomes 2 ratio 2. What this simply means is that 2 moles of hydrogen produces 2 moles of water. So the mole ratio actually helps you to understand how many moles of a reactant produces a particular number of moles of a product. I trust you're getting it. How about if we're asked to obtain the oxygen to water mole ratio? Well, that's also easy. How many parts of oxygen are in this chemical equation? We have just one part, or 1 mole, whichever one you'd like to use. How many moles or parts of water do we have? We have 2 parts. So that simply means that the mole ratio becomes 1:2. Now, if you are to depict this in simple English, we would say 1 mole of oxygen produce 2 moles of water. Can you see how this is being played out? Easy, simple, and straight to the point. Now that we understand that, let's move forward and see if we can treat a number of examples. So we have this equation on the screen right now. We are to identify the reactants, identify the product, and we are also to find out what the magnesium to oxygen mole ratio is. Well, the first thing is the reactants are on the left side of the equation. These are the reactants: magnesium Mg and oxygen O2. Next is the product. The product is on the right hand side of the equation, magnesium oxide MgO. And then finally we were asked to calculate or to obtain magnesium to oxygen ratio. So let's write out for magnesium. How many moles or how many parts of magnesium take part in this equation? We have 2. You can see it over here. So we have 2. Let's write that out. Ratio. How about oxygen? How many parts? There is no number in front of oxygen, so it means we have an automatic number 1. So this simply means that the mole ratio becomes 2:1. What does this mean? It means that 2 moles of magnesium Mg reacts with 1 mole of oxygen. That's what these 2:1 simply means. So you can see how the coefficients have helped us to depict the mole ratio and to depict the amount of substances that are produced. So let's consider this equation on the screen. Another worked example on the screen right now. The question says how many moles of hydrogen react with 1 mole of nitrogen? How many moles of hydrogen react with 1 mole of nitrogen? So step number 1, get the mole ratio. Get the mole ratio. Get the mole ratio. What is the mole ratio? We have hydrogen and we also have nitrogen. So from the chemical equation, how many moles of hydrogen react? We have 3. Ratio. And then how many moles of nitrogen react? We have just 1. So this simply means 3 moles of nitrogen react with 1 mole of, or 3 moles of hydrogen, I beg your pardon, not nitrogen. 3 moles of hydrogen reacts with 1 mole of nitrogen. So that simply answers our question. How many moles of hydrogen react with 1 mole of nitrogen? 3 moles of hydrogen. So can you see how the mole ratio was used to get the answer? Let's move on to example number 3. Example number 3 says read this equation like a sentence. Okay, this can be done pretty easily. To read this like a sentence, we have carbon monoxide over here, and there's a coefficient of 2, so we have 2 parts or 2 moles of carbon monoxide reacts with 1 mole or 1 part of oxygen. How did I get 1 part of oxygen? You can see over here oxygen is standing alone. There is no number in front, so it means it's an automatic number 1. To produce 2 parts or 2 moles of carbon dioxide. Pretty easy, pretty simple, and pretty straight to the point. Trust you're getting massive value for what you're seeing in this video. So the summary of all we've been saying since the commencement of this video is reactants are simply the starting substances in a chemical reaction. The products are the substances formed after the reaction. The arrow means produces or gives. When you see an arrow, this arrow simply means produces or gives. The coefficients tell us the quantities of substances, and the coefficient provides the mole ratios. So balanced equations can be read like sentences, and the ratios come directly from the coefficients. I trust you got massive value for what you saw in this video. If you did, consider liking, sharing, and subscribing. In the meantime, before we anticipate the next one, here are some practice questions I'd like you to try out your hands on. First, we have identify the reactants and products in this chemical equation. Secondly, we have consider this equation, identify the reactants, the products. And then thirdly, we have consider this chemical equation. What are the coefficients and what is the sodium to chlorine ratio? Answer these questions. I'll drop a solution to them in my next video. I'd like you to look out for that. Then question number 4. Consider this equation on the screen right now. How many moles of oxygen react? How many moles of water are formed? And then we have this chemical equation, and we said read this equation like a sentence and do the same for the next one. Go ahead, answer these questions, and I'll see you in the next video. Before then, here is a challenge question. I'd like somebody to try this out. Consider the equation on the screen. Question number 1 says, what is the aluminium to chlorine ratio? How many moles of chlorine react with 2 moles of aluminium? How many moles of aluminium chloride are produced? Answer them, and let me have your answers in the comment section, and I'll reply as many as I can. Up next, we're going into the concept of the mole itself. I'll see you in that next video. Up until then, stay blessed. Bye.